Hi everyone, we're going to talk about multiplying probabilities, and there's two terms you need to know about, and that is independent events. If two events A and B are independent, then the probability of both events occurring is found as follows. Now you've probably seen this before, and we actually did it in a previous video. Sometimes it's written like this. It's A union B. This means and. So instead of and, I wrote it like this to reach a higher audience. So as long as you know that these mean the same thing, you're good. And then you have dependent events. So we could write this as a probability of A and B like that if you want. And the main thing you need to know about this is if it's independent, that means it's with replacement. So if you see with replacement, that means it's independent. If it's without replacement, that's going to be dependent. So those are your key words. And have a few examples here. A box contains 5 triangles, 6 circles, and 4 squares. A figure is removed and replaced. So it's replaced. That tells us right away that this is going to be independent event. I'll just put independent. What's the probability that a triangle and then a circle will be picked? So all we're going to do is multiply our probabilities here. So the probability of a triangle is, how many triangles do we have? 5 over, how many total do we have? 15. Make sure you have a calculator ready, because I already did all this. And then a circle, so that's 6 over 15. If it's independent, the denominators stay the same. Then you just multiply that and reduce, and you get 2 over 15, which equals 0.133. Okay? Now, sometimes my students have a problem with this word problem. So, and it's mainly they don't know what the first counting cards are. So these are just like cards that you would see in kindergarten, where the teacher shows you 1 through 20. So it's just these cards, 1 through 20, and you have to recite there should be 3 dots. But anyway, so that it's just cards with numbers on them. So what's the probability of drawing 2 cards showing odd numbers from a set of cards that show the first 20 if the first card is not replaced? Not replaced means it's dependent. That means our denominators should be different. So the probability of odd would be 10. So there's, half these numbers are odd and half are even. So that's 10 out of 20 are odd. Now we don't replace the card, so we only have 19 left. And we only have 9 odds left. And you multiply that across, and you get 9 over 38. Or that's exact solution. Approximate would be 0.237. Okay? And we have just a couple more. This case, we have the 7, the 3. I really don't care what they are. They're jawbreakers. So we have lemon, cherry, and rainbow. We want to select 2 lemon. So 2 lemon, that would be 7 out of 18, I guess. And, whoops, we're going to select 1 at a time. So we're going to replace it. That means it's going to be independent. Means my denominators stay the same. So we have 7 over 18 times, since it's replaced, we can get 7 over 18 again. multiply that across, you should get 49 over 324, or approximately 0.151. Okay? In this case, we're not replacing. We have quarters, nickels, and dimes, and we're going to draw three, or select 3 coins, and we want to select first a quarter, so that would be 3 out of 14, and then we want to select a dime. So in this case, we still have 4 dimes, but we only have 13 coins left. And this is dependent. That means my denominators are different. They usually go down by 1. And then we need to select a nickel. We still have 7 nickels, but we only have 12 coins. So this equals 1 over 26, which is approximately 0.038. Okay? I basically did a part 2 of this video that has a little more advanced problems, but this is basically what you need to know. So, independent, the denominators stay the same, and it's with replacement. Dependent, the denominators are changed because we are not replacing. It's without replacement. Okay, thank you and have a nice day.